Okay, good morning everybody. Welcome to this webinar. The topic of today is the EGI Open Data Platform. This new service will be the core service of a new solution EGI is developing, the Data Hub solution. This will allow to fully manage distributed data within distributed infrastructure. In particular, the EGI Open Data Platform will provide services for the distributed data management, such as, for example, sharing data set in a transparent way between virtual machines running in different EGI federated sites, but also will provide services that would allow to share data set as mechanism to automatically publish data set on open data repositories such as DataSite or OpenAir. The EGI Open Data Platform is being developed within the EGI Engage project. It's currently a prototype, and for the distributed data management is based on OneData, a technical solution developed by Safonet that is going to be further extended within both the EGI Engage project and the Indigo Data Cloud project. This webinar is organized first of all with a presentation where Lucas Dukta, the team leader of the EGI Open Data Platform and OneData project, will introduce you the concept of the EGI Data Hub and the main feature of the EGI Open Data Platform and OneData. Trying to clarify you the difference between these three elements. Then we will have a demonstration where we will show you the main feature currently available of OneData, the technical part of the technical component of the EGI Open Data Platform. Then we will have a slot dedicated for further discussion. During this slot, you will free to do any questions. We will try to answer, to ask for any clarification, and and also to express your interest or not in this kind of solution. And also, if we have any specific requirement you think the current design is not accomplishing, we can take it into account for the future enhancement of the platform. One of the main objectives of this meeting is, first of all, trying to make you aware of this new solution EGI is starting to provide to its users. And then, if you, after this meeting, if you think this product could be a valid solution to integrate your application, your services within the EGI infrastructure, please contact me, since the idea is immediately after this webinar to start to support a set of early adopter communities willing to test and validate this solution. Okay. Okay, I think now I can ask Lucas to share his slide and start with his presentation. Lucas, you have the presenter rights. Can you share your slide?
Yes, okay. I would like to ask if the microphone is set properly, because on the chat I've got information that it's too loud. Is this the current volume? Is this okay?
It's a bit too loud. If you can decrease a bit.
I will. What about now? Is it better?
It's better. It's better for
Fantastic.
that.
Okay, so in the meantime, I will start sharing my screen. By the way, Diego, I'm not sure Ian text something about the limits to the room. Are there any limits to the room? Because there is on the chat something.
Yeah, I would say it should be big enough. The limit is 200 attendees.
I see. No, so we don't have 200 people for sure. It's only 34.
Around the issue.
Okay, so let's start. Okay, I'm starting to share my screen, and it's going to be can you see my screen now?
Yes, Lucas, now it's in full screen mode. It's fine.
Good, good. So, contrary to the what Diego said, that at the very beginning I will show the slides, and then later I will try to do the demo presentation. I browsed my slides, and it looks like I have 20 slides. So I want to avoid death by PowerPoint for you. So I'm going to intertwine no demo with the slides. So it will be like combined thing. Before we start, there is a very important thing to clarify. You know, Diego and Matthew asked me to put attention on that during my presentation, because there are three components, three elements mentioned in EGI world related to data management, and they are similar to each other in some sense, but and it's important to understand what are the differences. So one of the components is one data. Another issue is the brand we call recently EGI Data Hub, and another thing is EGI Open Data Platform. So one data is a software stack for distributed data management, and I will demonstrate you later how it works in practice. This software stack allows us to build a solution which is cross data center solution, which allows you to share the data, do the computational data, analyze everything like a virtual file system. EGI Data Hub is a concept how to exploit one data for open data collections, which might be interesting for EGI users. And so it's for some sort of publicly available popular collections. And using one data deployment provide them in the user an easy way to get this data. Easy way to get access to this publicly available collection on the premises of FedCloud. This is somehow the response to this could be a response to the issue that we got a news that Amazon replicated Sentinel data, or Google is replicating something. So this is the answer for these problems. And the last thing, which is I'm going to mention today in my presentation, is EGI Open Data Platform, which again, this is an extension. This is a development build, supported by EGI Engage, which allows us to extend the distributed data management platform to make people interested in sharing their data easier. So to allow people to easily share the data they have in the distributed manner, managed, and to register this data in the public repositories. So this is before we start. And I have the three parts of my presentation. First part will be about one data, second part will be about EGI Data Hub, and the last one about the ODP. So what I'm going to show you today is the demonstration of, basically I want to bring some basic concepts of one data, how one data works. Otherwise the rest of the presentation might be confusing for you. And what I'm going to show you today is that everything which is built on the release 3.0 of one data, which we released in the beginning of April, and now this is version beta 4, and then this version is publicly available for tests, and you can go to the beta1data.org to see how it works. However, it's not easy to start with that. Let's wait for my presentation. I will just show you the first steps and make the life clear for you. So the big picture for one data is that we want to respond to the users the concept that the problem that users want to have clear access and transparent access to the data. We just store it around the world. Sometimes the data is stored in the private repositories of the lab centers, and some data is publicly available, large collections. Some of the data are as community collections. And everything is very difficult to process in the federated manner on the cloud, and we want to simplify their lives, users' life, providing a kind of solution which brings a virtual file system covering the distribution of data and making the data available wherever they go and on whichever technology they want to use. Some of the user wants to access their data using POSIX as a POSIX virtual file system. Some of the users want to use CDMI to access the data they have, or they want to use both. So we want to answer both of these questions, both of these problems. So very quickly, because I was showing this slide too many times, very quickly, the idea is that we have the world of users. The user might be collected in groups. This is typical for federations, for communities. And they create some data spaces, and they want to store the data and share easily the data between them. So like in this case, user 2 has access to two data spaces, and user 1 only to this one. Of course, in this world, we could have lots of these data spaces accessible in the free manner based on the permissions to access this data space. So if you create a new one, the user let's say, could create a new data space on the fly, and then to share this data space to anyone in the world, no matter from which federation he is and from which technology he wants to use. To log in the end, we are able to provide a solution which can bring the gap and can bring a solution which is easy to use in even between the heterogeneous environments. So from the user point of view, users, they don't care how it works behind the scene, and they want to make it's easy and fast, and they want to make it as simple as possible. So from the user perspective, they see just the idea of spaces. However, behind the scene, there is a complex could be a complex infrastructure, which allows us to, which is basically the software stack which consists of one data. And there's this major component is one data provider, which someone could deploy on the premises on a repository, on the data center infrastructure or private infrastructure. And when the user creates a space, the space could be supported by many providers. Supported, it means that the actual data which could be stored there could be in the end stored in has to be stored somewhere on an actual storage technology, which we don't know which is the preferred storage technology from the system administrator, because from the user perspective, we don't care. We just want to have the data. From the administrator perspective, is to make them the easiest and selected storage they have to offer the community the space. So in the system which we are presenting, we are at the moment supporting underlying storage technology based on variety of POSIXes storage, so it's NFS, parallel file systems like Lustre, GPFS, or we are supporting at the moment Ceph and Amazon S3 storage, and there is an OpenStack Swift in preparation this month. So the idea is like that when you support the space, the providers can start communicate to each other in the P2P manner. So when the provider supports the space, two providers supports one space, they start to communicate to each other. So they can exchange information about this space. And wherever the user goes, users can access their data in the most efficient way as technically as possible. So when the user 2 goes to this data center and asks about the space 1, she will get the ability to get directly data from the storage, because the data could be replicated here or it's here, could be here. But when she asks data from space 2, in fact, this will require communication to remote providers supporting space 2. So this is a very generic concept. If someone has something is not clear, please interrupt me somehow and tell what should I explain more. But my point is to demonstrate this on the live system in a few minutes. So it will be a just live demo. This is the case for the demo. So before we go to the demo, one data is consisted of three components. One component is named one zone, another one provider, and there is a one client. Okay, starting from the top, one zone is the component which allows us to control the user authorization and also orchestrate providers in terms of authorization and authentication. One provider is a software stack which is actually managing the data on the storages, and one client is a software based on the Fuse driver, which allows you to mount a virtual file system on your Linux operating system. Or you could have a request from REST API using CDMI or graphical user interface. So before now I think is a good time to do the demonstration, unless there is some urgent question. I'm trying to. Okay, so if there are no urgent questions, I will just go to the demonstration. So here we are. What I have here is that it's the login page to one of the One Data World. It's zone for the deployed by Indigo Data Cloud project, which supports the evolution of One Data as well. And in this system, I can log into the system using OpenID providers, including the ones which are popular in the market. So I'm selecting at the moment to log in one of the providers. So let's click on the Facebook, and answering in the meantime EGI EII. Yes, EII. So there is an ongoing effort to integrate EGI single sign-on to the system, exactly like that what I did for Facebook. We are waiting for the components to be delivered by some other partners. Peter Solania was mentioned that this component will be available in June. So anytime when the component will be available, we will just integrate. This is fairly simple integration with another OpenID provider, because we are already prepared the system for many of them. So this is an example of the system where I don't have nothing. I don't know the component which is named there. It should, maybe Diego knows. It should be available. Maybe Diego knows the component. So when I have this example, I have nothing in the world at the moment supported, because there is one space created for my personal usage, but no provider is supporting that space. So I cannot do anything with that. I could get a token and ask the provider to support this token, but in the end, of course, it will take a few minutes of my presentation. So for the sake of the presentation, I prepared another account, this time based on my GitHub, which is slightly different. And in this case, as you see here on this map, I can see one of the providers. So is that there is a existing one provider, INFN provider, that deployed the INFN facility, which supports my space. That allows me to click there and go to my files. However, this wouldn't be that exciting to demonstrate when you have only one provider supporting one space. For that case, I prepared another third account, this time authenticated by my Dropbox account. When I have when I have more spaces, which is more realistic, and I have many providers supporting each of the spaces. So when you see here, you can see that I have a list of data spaces which are supporting by many providers. So one of them is supported by NFN, AWS is supported by AWS, and to explain you what is here on the map, this is the provider deployed on actual Amazon cloud, which data we supporting is data supported is supported by S3 storage, which Amazon is there in states. This is the UPV deployment, which is in Spain somewhere. and this is INFN Bari deployment, which is in Italy. And as you see here, each of those providers supporting some of the spaces. Some of them are, I especially created a very complicated scenario where the different providers supporting different data spaces, but there is as well some intersections. So let's say HVP scans is HVP scans is supported by INFN and UPV, and my private space is only supported by INFN. So just to start using the system, I can click and select whichever provider is available here, because if the provider is supporting one of my spaces, it allows me to log into the graphical user interface. So I'm clicking, let's say, INFN, going there, and now I'm logging to the provider, and now I logged into INFN, the data deployment of INFN. And I'm browsing my data through INFN. But as you see here, there is a list of all the data spaces which are available for me. And I can switch between them by clicking here, even though I can access the data, even though the data is not even supported by INFN in that case. The AWS sensor, if you were looking carefully previously, is supported only by AWS. And let's say HVP scans is supported by INFN and UPV. So I can see all my data here in one place, no matter where the data is located. To see the location of the data, I can open a file, and then I can check some, sorry about that. No, not this time. So I can check the distribution of data, of existing data by clicking distribution bar. And this is a very small file, 221 bytes. And at the moment, this file is fully replicated between two locations, INFN and UPV. When I will go to my private space, I don't know if I have any file here. Oh, here is the file. And then let's say this file. Then I will see only INFN. As you see, this data is supported only by INFN. So this is the graphical part of the user management. Is so simple like that. No matter the complexity of the distribution, you see everything at your fingertip. And when you actually wants to use the data, of course you don't use it through graphical user interface. It's just for the sake of easiness of the data management. You are using a client. So to access the client, we need to run the Fuse client. And here is to run the Fuse client. I need to have a token which which delegates my current user rights, delegates my authorization to the client because it's a command line application. So I'm clicking here and copy pasting that, and I have a client, a terminal which allows me to run the client. Everything is in Docker. What I'm showing you today, everything is distributed as Dockers. So I have this is just a sake of the simplicity of the testing. In the end, of course, there are RPMs and depths are as well provided. So this is a very simple Docker. You just need to remember this and this. This is the authorization token environment variable which need to be passed to the Docker to be executed. So now I'm running this client. The script is basically collecting. This script is collecting the authorization token, and now it executes the Docker, and this Docker is connected. As you see here, the Docker successfully connected and mounted my virtual file system to directory MNT client. So now let's I will enter this Docker goes there. I'm presenting this on my Mac, so this is the reason why it's easy for me to show everything through Docker. So you have maybe this directory will be easier to understand. We have this, as you see, there are sometimes you have to be prepared for problems with distributed data in the distributed data system. Sometimes the infrastructure might be not responsive. like this case. We have a lot of problem with Amazon, by the way. I've deployed the machine on Amazon, which it's one of the, maybe not the most expensive, but relatively expensive machine, which allows us to connect the data there. And this machine is sometimes very slow. Sometimes works fine, and sometimes is extremely slow. As you know, it's the whole thing is very slow, and sometimes there are timeouts in accessing the data. And as you remember, AWS sensor, this is the data space which was supported only by AWS, and there is no other way the system can get this data. So this is why the error is emitted here. So I don't know if I will be able to go there easily. Spaces, it's like HPP scans. As you see here, I was able to skip this directory in my system, even though at the moment Amazon is not responding. Maybe it's responding, maybe not. But at the moment the system there are problems. There are problems with Amazon. But there is no problem. We can live with that, because my demo will definitely prepare for that scenario. At least I hope. And if you go there to the different directories, I can, let's go back to UPV. I don't know, maybe this is my network, but it looks like UPV is not responding as well. But we have the INF. So let's see what happens there. Okay, I have a client which allows me to connect from my laptop here. On my screen, I have the client which is connected to my laptop. Then I split my screen to 4 places, and this is the client which is connected to Amazon. This is the client which is connected to INFN instance, and this is the client which is connected to UPV, and this is my laptop. So in practice, I should be able to switch the directories wherever I go. However, this INFN Amazon problem is still ongoing. So I need to. There are timeouts like 45 seconds timeout to reach some directory. So if I know it's by scans, I can switch the directory between. And this is the actual HBP scans directory, is actually the most interesting one, which I wanted to demonstrate you anyway, because it's supported by 2 providers, and these providers are replicating data between each other. So this UPV is in Spain. This is my laptop, and this is my the same directory is everywhere. So to understand the whole concept is like that. I just need to switch for a second to the graphical user interface to show you. So when you have this HBP, we have two instances, UPV and INFN, supporting this directory, this data collection. And INFN, whatever I write in INFN stays in INFN. Whatever I write in the UPV stays in the UPV. However, when I want to read something, wherever I go, I should see exactly the same data collection. and no matter where the files are created. So let's do the magic. This, I hope it will work. As I say, this is a beta. So my laptop in this scenario is not very interesting because I'm just connecting through my by my laptop to INFN, and but this client is connected locally. So when I create a file, when I created a file UPV logs, and I created the file INFN logs. This data is should be everywhere. I don't know why the whole system is very slow now. It looks like there are some delays. It's the typical cloud configuration. So I haven't deployed on purpose that on an actual dedicated resources. I just wanted to deploy it on the actual cloud any user can get. In practice, it works pretty well. However, I know sometimes that there are, especially on some of the cloud, the smallest resources I got, there are some delays, and sometimes it hangs a lot of time. I don't know if this is related now with AWS, but this scenario shows you that sometimes there are problems. And in fact, if you want to have a high performance thing, you need to get all this data. You need to get the machine, faster machine, to make it faster. However, it looks like there are even communication problems between those locations, because the approach we have here is the eventually consistent approach. So as you see here, there are still some network. There must be some network problems, because there are problems with synchronization of metadata of these files. So it's eventually consistent file. So after, let's say, some time, this data will be synchronized. However, when I write anything there, I should be able to speed up the process of synchronization of the data. Apparently not. However, the most complicated scenario is when I create a file. Let's say touch file all logs. This is how the live demo looks like. So sometimes the things are not working, even though 5 minutes ago was working perfectly. I'll see here now I wasn't patient enough. So this file is the data is coming, and this file is starting to be synchronized. So this shows you that this is actually a synchronization which goes beyond one provider. Of course, in reality, you don't. This is not the system you want to synchronize your application on the files which are saved on the different locations. The whole point of the system is to make transparent access to the data wherever you go, and to provide a means of replication the data between the locations in that way that user don't care about this in practice. So if I go to the graphical user interface, I should be able to see my files which I've just created, taking into account the fact that for some reason it's very slow today. I don't know why, but anyway. So this is just to show you the concept of the whole scenario. And if I want to go back to my presentation, is that we are able to create this is the scenario, this is the solution we have. I don't have much time, so I will skip the slides there. And the point is that what you show is what I was showing you was the one zone which has many providers, which each of the providers can support many data spaces. And more importantly, what we want to achieve by the end of June is to make this several zones communicating to each other in that way that they can automatically in the world discover themselves if the zone's owner wants to do that. So that allows for data sharing and space sharing between users coming from different locations, and even from different communities. So this is probably even more important. So this zone, in fact, is the place where the authorization is in place. So, for instance, EGI could have one zone. Some community could even have the Human Brain Project. They could have one zone, another zone, and even though the zones are working on the different authorization community, we are able technically to integrate those things and provide the users ability to access the spaces wherever they go. You know? Okay, so my live demo is about that. In practice, what we were working on the actual system, not the system we just what I was showing you is 3.0 beta 4. When we were working on the actual system is the system which works in a very high performance manner. For Human Brain Project, the pilot, we have the deployment which is able to achieve on one single node 55 gigabit per second throughput, and this is saturating. That saturates InfiniBand. Okay, so and we achieved that in five simultaneous streams. So to summarize, this is one data is a distributed repository center. We have a pluggable architecture. At the moment, we work with S3, Ceph, and POSIX file system. OpenSwift Stack is in preparation. And there are metadata as well, which I haven't touched up today. We can prepare the extra demonstration just for metadata. Is a long topic, and there are features which allows us to easily migrate the data between the sites. So the user could either read the data on the fly from different locations or replicate the data between the locations. Second part of the EGI is of this presentation is EGI Data Hub. So before I can go into that, if there are any questions about what I was showing now, is that something we can discuss right now. If not, then I will go to Data Hub. Data Hub is basically some sort of unified deployment of some sort of deployment of one data platform for distributed environment for replication publicly available data. So we want to select. We would love to select a few very popular community data specific collections and offer them as a solution which can be easy accessible in that way. In that way that you can have it as a data space. And the current landscape is like that, and we have the existing repository. Some of the repository are even replicated somewhere, and we have the resources which are not easily connecting to the publicly available repository data. And the concept of EGI Data Hub is basically to build a kind of virtual file system on top of existing infrastructure on whatever providers EGI volunteers for this area adopters can provide us. Could be S3, Ceph, or NFS, or Lustre. And on top of that, replicate the existing collections and allow users to access them in that way that the collection is in the list of the collections that they could have in the system. So how to get to this collection is fairly, we believe that the easiest way to get to this collection is the place where the data owners are maintaining and discover data. So in that place, let's say we have the data collection owner, which has a data discovery service, web service. we could plug in there our JavaScript widget, which allows us to, when the user clicks on this, let's say this cloud icon, there is a pop-up in the web browser, and the user is required to be logged in through EGI SSO, and the user then decide the name of the collection, how the collection should be called in his data spaces here. And when he clicks saves, everything goes to it's just configuration of the platform, which allows you to see the user as allowed to see the spaces. So this is one of the application of what we want to have. And this is basically the most important thing, is that we don't want to replace existing data discovery mechanisms, and we just want to integrate with them and provide a focus on the distributed data management, distributed unified access to the data part. This is what the data hub could be, and if we find enough interesting collections for the users and supporters for that. And the last thing is the EGI One Data Open Data Platform, which is the extension of One Data, in that way that when you have a collection, we want to make it easy for users to click and make the collection available into the open data discovery services like DataSite, OpenAir, and to create the DOI for this data collection and provide some tracking mechanism who uses that data. So it's some sort of data as a service solution for open data, so you can easily convert your data to open, because everything that I was showing here is under some configuration. I can invite any user to share my data. However, I can even send this token to anyone by email. Then the guy who gets this data will be instantly have access to my space, which I was sharing with him. However, this should be easier and more automatized. So the technology behind the scene is already there, the interfaces are there. So now is the matter to integrate that with the full process. It's based on some community requirements, which I'm not going to read now, but it slightly reminds some concept like Git fork or Docker pull and push. For those who don't know how it works, I have a short animation showing how it will work. Dataset is the collection of private repository data set. A user could have a data collection, some set, and then he decides to create a snapshot, because as you know, all the open data usually should be, especially when you publish them through DOI, should be read-only first of all, and it's good that the data is not changing. So we have a technology which allows us to create a snapshot on the data collection. And then in the community, there could be someone who is in charge of data publishing. When this publishing is the process which we are providing by API. So the owner is, this guy is calling our API, which in the end creates a DOI, and then it will register the data in publicly available data collection discoveries, OpenAir and DataSite, which we are talking with them. And then if someone has discovered this data, DOI could be used to visit, the user could visit the collection, and then they can check what is this collection about in terms of some web page which we are rendering there. And when it's there, user can mount this data based on the DOI, or it could be even forked, in the sense that there could be replication process between the data collection to keep clone of the data, which is interesting for us if this data set is interesting. If not, so this is, as you see here, Open Data Platform is the platform which is focusing on the process of making the existing data you have under any on your spaces here to make this data available not only to the users which are known and invited by name, but to anyone who wants to access that, and make these data spaces available in the same manner as the data spaces are private data spaces and publicly available data spaces available in the same way. So how we want to deploy that, I'm not sure if I have enough time for this diagram. So this is the place where we want to deploy the software stack on the several EGI resource data centers. And this data, when the user registers this new public collection, when the data collection owner registers this data, making publish, I'm sorry, when the user make publish the data, they are automatically registered in OpenAir and data site, and that allows us to other user to discover this data. And when the user discovers this data, the user could be redirected to one of the provider, one of the EGI resource center, which currently hosts the data, which is published by the Open Data platform. There are some scenarios as well which we want to tackle in the second part of the project to migrate the data to the external repositories, persistent data repositories. So when someone creates a snapshot, the data will be migrated to external repositories for the long-term preservation. So this is a very complicated diagram. I will skip it. And for now, we work on the open data publishing ACLs, generation of DOIs, integration with the DOI minting service, and implementing of the protocols for metadata processing. Because everything what we have in the system is not only data, but there are as well metadata part involved all together with files. And implementing of ORI PMH will allows us to integrate with externals, externals data discovery providers. So when you have a data collection, when you click it publish, it should be compatible with a few very well-known data discovery services. And this is under implementation, and we want to demonstrate that working during the Krakow meeting, the digital infrastructure meeting, as a new feature of the platform. Nearest to a future plan is basically we want to release the final version 3.0 stable one. The plan is to do that at the end of June. This is all in line with Indigo Data Cloud effort. At the moment, we work with the new storage drivers. As I mentioned, it was Open Data Swift, and there are new features related to improving web graphical user interface, including the transfer management through graphical user interface. At the moment, I can't show you in the graphical user interface any mechanism to monitor the transfer, what's going on behind the scene. I cannot even initiate the data transfer through graphical user interface. It's only through API. But what we want to do in the nearest future is to integrate the whole data transfer into the graphical user interface. This is the really interesting and more important request from the users. In terms of the EGI Data Hub, the selection of data collection to be replicated to EGI, this is one of the steps. Then selection the resource centers willing to support this collection. So in that sense, to provide the storage and the CPU resources for this collection selected, and then to integrate the first this JavaScript widget I was showing with some sample collection. So to make the whole loop, technologically we are already prepared for doing that. At the moment, this is a matter of selecting the community. And the Open Data Platform, as I mentioned, the extensions for publishing DOIs and publishing the data is planned for the Krakow digital infrastructure meeting. Technically, according to the project, it's month 20, but we want to make it a little bit faster to make it a nice demo. So this is my last slide I have to show you.
Lucas, thank you very much for your presentation and demo. I'd like to ask people if they have any question. If you have a question, you can raise your hand and I'll give you the word.
Okay, I see there are a few questions which I didn't notice in the text in the chat. Maybe I will start answering them first. There is a question about licensing. So first, Michael Borg, can community use its own AI? Yes, this is the exact case, the concept for zones. So when you go here and see the zones, this is basically the place where people are authorizing on the same way. So if you have something specific for your community, you just create your own zone, and then it allows your users to access the system. But when the user accesses the system, there is no barrier to access different zones. So if someone shares data from zone 1 to the user zone 2, even though those users are authorized in a different way, originally in a different way at the very beginning, then it's possible to share the data between in that scenarios. It's that because we have a different protocol for data exchanging, inter-provider protocol data exchanging, which is based on different authentication mechanisms and different mechanisms for initial user authorization when they start logging. So this is possible. I'm trying to see about the licensing. There are about the open data license. Yes, there is in the requirements analysis, when we did the requirements analysis for what people are looking for, so they are looking for a solution which allows them to, when they're publishing the data, they want to select the license and the limits how the data, open data, could be used. In many cases, this is just the license agreement. So when you are attaching data space to some public data space to your private set of the collections, set of data spaces, you need to agree on some license, like let's say license, which are typically for open data. There are a few of them very popular. In terms of there were some requirements to allow people collect number of users which are using the data, and to limit to some extent the anonymity. So in that sense, that even though the user is logging through in Google or through Dropbox, we should at least see his email address as a user of my data collection. So this is one of the feature which is the part of the open data platform. Any other questions which I skipped from the chat? I'm sorry, it's difficult to find.
Genevieve?
Oh, there is one question. What are some? Oh, come on, please.
Go ahead, Genevieve.
Okay. What are the terms of use for this service?
Open data, one data EGI is based on open source code. This is implemented open source code under currently under Apache. Line 2.x is the MIT license. Line 3.0, which I was trying to demonstrate today, is based on Apache 2.0 license. So basically, it's open source software.
That is for the software, but for the service, who offers the service? In fact, is it EGI? Is it instant?
The services should be deployed on the EGI resource centers. So this is under the data center the decision how they want to support the communities on which license. But this is up to them if they want to use it.
Lucas, maybe Genevieve means the web interface. Am I right?
The service globally, because as user, I would like to know what are the terms of service I can have, or I may agree with. Perhaps it's not a clear question. When I use Google, there are terms of service attached to the search on Google. What are the equivalent terms of service for this open data service or EGI open data platform?
Actually, this is a very good question, to be honest, and it's up to take a decision by EGI.eu how we want to, on which terms of the condition we should provide EGI EGI data hub, for instance, because we are replicating the data collections, and then we are providing some services to anyone who wants to use that. So that's the point. But when they are creating a link to the data sets collection, they should be able to see what are the terms of condition. So
Yes, and I did not understand that the user has to register to a VO. Is it true?
if this is an EGI SSO, a single sign-on, I'm not an expert how it will be integrated with EGI infrastructure, single sign-on, but I guess there are some relation between VOs and the users which are able to log in. So first you need to have the account there.
The account, but
Diego, do you know?
Yes, currently Genevieve, you have to see the service as one data such as a service on top, running on top of the EGI resources. And it means, for example, if we consider the cloud scenario, a user can start a cloud machine, and then on top of this cloud machine can exploit the one data service. Then when the user has to create the virtual machine, in this moment the user has to use his EGI credential. Then when the user has already created the virtual machine and want to start one data, he doesn't need any more the EGI credential at this stage. We have planned to introduce also the virtual organization support within this service, but it's not available yet. Then at this stage, you can see, as described before by myself, as a service on top of the service you create with your EGI credential. But the target is to allow to fully integrate the AAI, the EGI AI with one data the other platform quite soon. As I brought during the webinar, we already have planned an action to integrate the open data platform with the new EGI AI and the PHP proxy. This will be done by the support.
okay. Thank you.
Welcome. There's a question from In. Go ahead.
Hello, can you hear me? And my question is related with the usage of the data for when we have a data can manage on this MySpace. And next step, I can imagine researcher want to processing analysis their data. So how it can connecting with processing analysis application, and can they use any data across the site?
So I think that if you have a problem for which you process the data, you usually are processing some collections which are equivalent to our concept of data spaces. You have some collections which are community-wide, so you are processing a data which is based on the community, collected by the community, but usually you have as well your private data, which are keep somewhere on your premises, and we want to integrate this private data into the loop as well. And in the whole system, you just get the list of spaces. You can switch and you can use all the data which you have there. So the problem is how to convert your collections into the data spaces, or how to map maybe not convert, how to map the collections you want to process for the data spaces to the data spaces, and then to see what's going on there. If you can go to any cloud, Fed cloud resources, and see exactly the same file system where you go. I'm not sure if I.
It's not a guarantee that I have this MySpace, and also I have a space for computing at the same place, but I still need some other resource for computing and stage data to that place.
Yes, and this is exactly, this could be another data space you have access to. It's like I was showing, I have private spaces. This is which space where I save my data, and there's a place where you keep your results if you don't want to share it with someone else, or you want to share this result with a smaller group. There is a question if there is can be space mounted on several nodes on HPC cluster. This is exactly what is the point. You can execute the client, one data client, on many nodes and have access to the data space in the same way wherever you executed this client. The difference is that you don't. It's better than the cross data center synchronization, because in the cross data synchronization you need to wait for the eventually consistency of the file system, which is sometimes delay up to 10 seconds because everything is asynchronous in our system. If you are working on the local file system, is more or less in line, so you can see it like a normal virtual file system. This was the question for Laura Del Camo.
Lucas, about this topic, Luis Grassi also added another question. Back to HPC, if networking is not that fast, are you at least guaranteed to avoid conflicts?
Okay, so there are. It's a very good question about conflicts. It's like that. It's in our system. It's very easy to create a scenario where you not easy is a wrong word. It's possible to create a scenario where there are two users connecting to the there is a one user connecting to the same directory, to the same data space, and he connects to this directory in different locations. And because everything is asynchronous, of course, when you create a file there, we are not checking the whole world to see whether this file is available. We just create it. So it's possible that you could create the same file name in the same directory on different ends. And we are prepared for that situation, and we are solving this problem as in that way that if you create a file A in the one location and a file A in the second location, these files are different files, even though they are named the same. So when you write the data at one location first, you write to the same file you created there, because the names are tagged by the location where the file was created. So if there is a conflict in file naming, so we are taking the file from the location where you are currently logged in. So in the end, this is a better evil. Of course, it's not a general solution for this problem, but there is no good solution for that problem. But you have some consistency of your application, so your application won't crash in the middle. However, the problem of the file consistency is even bigger, because we are working and synchronizing the file system on the block level, or actually on the chunks level. This is a little bit more complicated, but you can figure this out as a block. So when you actually create one file, wait, let's say this 10 seconds or a couple of minutes, and to go to a few locations in the world. So you will be actually able to write to the same file at the same time. So this is a typical block file conflict. But this is exactly the same scenario when you have a network file system, which is not operating on the logs, which doesn't provide you logs on the blocks, because you can end up with a random thing, with random inconsistent data. So your application should be aware of that. There is a technology which we wanted to implement, the logs mechanism for the file system, at the file system level. Even in version 2.9, we implemented that. There is a feature like that. However, first of all, nobody was using that in practice. And second, if you go to the global thing, it's really slowing down your application. So, because we need to synchronize the state between all the players currently opening the files, there are split brain problems as well behind the scene, and the whole thing is very complicated. However, we have, to summarizing, we have the conflicts in mind, and there are some workarounds how we are dealing with conflicts. So this is the bottom line to the answer.
Lucas, there's another question from David Antos in the chat. Let me recall it. What is your experience with the scaling of the solution? What is the amount of data stored and number of files?
Okay, so this is I haven't mentioned about the scaling issue. So each of the most important components in the system is one provider, and second most important is one zone. In terms of all of those components are written in that massive parallel way, so they are scalable linearly, and the technology which we are using and giving us as the solution guarantees us, simple scale up to 500 nodes. So it means that we could bring a very large cluster maintaining the local provider needs. And the size of the cluster, it's correlated to the two things. One thing is the number of files, and the second thing is the number of users, simultaneous. By user, I mean clients, a few clients connecting to the system. However, the whole thing is built in that way that we are trying to not transfer data through one provider if that's not needed. So we are trying to make possible direct access from Fuse client to the actual storage behind the scene. So it could be a direct access to the S3 or Ceph or POSIX storage if it's possible. If it's not possible, then we are doing the backup fallback solution, and we transfer data through one provider. But I said this provider is linearly scalable, so you just bring more boxes, and the cluster is giving you more power. If you are talking about the transfer between the locations, like I want to transfer data from one location to another. So we are using a technology cluster-to-cluster migration data. So this allows us to summarize, to get a bigger traffic on the big WAN, I mean wide area networks, by summing up the traffic of many members of cluster from one side, sending data to the cluster at the second side. This is a typical scenario. For instance, at the moment we are doing the pilot for INFN. They have the 30 gigabit link between the locations, and there is no 30 gigabit network cards to do that. But we want to saturate that network. So at one side the cluster is consisted of tens of nodes, and the second side is on the same size. And then we try to scale up, then try to saturate the traffic. Okay. Answer from Luis. Can a user revoke access to already shared tokens? Yes, exactly. Yes, there is in graphical user interface, there is a button delete. So you just delete the token and then it's over. So you cannot use this token. The clients, the command line client cannot use these tokens. Is there a traceability of data when duplicated? I'm not sure what it means. It's we have the full interface, so you can have in the graphical user interface. You see the replication of the data, where the data I was showing today. So you can see where the blocks are, and there is as well a REST API which allows you to ask where actually my particular file is replicated to. In the worst scenario, it's possible that the parts of the file are distributed to the different providers. So you could have one part of the file in one provider, second part in the second provider, and third part in someone else. The system is prepared for that. Of course, when you will be reading that data, when the locally want to read the blog which is not available locally, we are replicating this data to your place behind the scene and provides you the missing blocks. And when they are replicated, the second time you are asking for the data, it's up there. So you don't waste too much time for replication. But this is only the case when your local provider you connected to is supporting the space you are operating on. Supporting, it means giving the storage, assign the storage to the space, because there are situations where you access. I was showing today the situation where we access the data from the remote locations, but I wasn't able, but this data was not supported by the local provider. So it means that every time when I read the blog or write the blog, needs to go, the blogs needs to go in the remote on the fly way. Can you set up a zone to auto-replicate between selected providers? You mean that way that there are a few providers which are supporting the same data space, and everything what I write in one place could be replicated to another place? Yes, this is the scenario which is possible, relatively very easy at the moment. But there is no setting inside one data at the moment. We don't have the data policy replication built into the system. However, how we are solving this problem is basically using an external logic. We call this data distribution logic manager. It is some simple Python script, could be, or something else, which watches on what's happening in the data space, because we have an interface which exposes you information about all changes on the data space. And when you see there is a new file on the new blog there, this logic is this distribution data logic manager is simply taking the decision. Okay, there is a new file. I want to make it replicated there, and it's able to call an API which replicates the data to a different location. So, but yes, this is fairly easy to touch it.
Any other question for Lucas?
Yes, please.
If there is no further question, I have a question, or maybe Costas is writing something.
What are the next steps with EGI open data? Costas, in what steps for what? In EGI Data Hub. So
I think the slide showed by Lucas where he described the next steps in the three different components we discussed today, the EGI Data Hub, the EGI Vanilla Platform, and One Data, should summarize the work we are going to do in the next months.
So what we have in the next months is that by the end of the June, the final version release of One Data 3.0 is the production one, hopefully. And there is by the end of September, as I mentioned, we want to demonstrate this open data platform scenario I was showing today in Krakow, the Digital Infrastructure Conference. And there is EGI Data Hub. It's the concept of deploying the software, but there are requirements beyond our means. So first we need to select the data collection which should be replicated, and then to find the provider supporting that. So if there are someone willing to support this early adoption idea of EGI Data Hub, I think this is the time to do that. I'm not the one who will be. It's probably Diego maybe know more about that, or what are the procedures with, or Matthew maybe more about that.
So this is Tatiana speaking. I think I can take the question. So besides the technical developments and the integration with the EGI AAI infrastructure, which are expected in the coming weeks, months, so in the shorter term, we need also to start testing activities with data providers, starting with public data, which is relevant to the user communities. And here we are in discussions with various data providers, including EBI, the European Space Agency, with a number of reference Earth observation data sets, and possibly other data providers in other disciplines like biodiversity and the agri-food sector. The idea is to demonstrate access and usefulness in this distributed file space. The next point is also, and this answers Genevieve's question, is to formulate the service and the terms of reference, because One Data is a technology, it's not the service. The service is the data hub, so we will have a procedure which formally involves the Services and Solutions Board, which is a board of EGI which analyzes the readiness of the solution, the business case, and the sustainability, as well as is responsible of defining the terms. And these will then go to a formal approval once we have successfully passed the tests that I've previously mentioned.
Thank you very much, Tiziana, for the clarification. Now, after
after this set of questions, I have a question for you, mainly for the user community that is attending the webinar. Since I'd like to understand which community could benefit of this solution, and if there's an interest to start an evaluation of the product as a heavily adapter, then what I'd like to, I can understand that maybe you cannot answer now, so you have to discuss internally, but I'd like to know if you think this could be interesting for your work, and if you think this is the case, please in the next days contact me, Lucas or Matthew, and see how we can support you on trying this new EGI services. Okay.
Okay. So thank you very much. Guess.
I think if there's no further questions, we can close the webinar. Any other business, any other points you'd like to discuss? Okay, then thank you everybody for have attended this webinar. Thank you very much, Lucas, for your demo presentation, and I hope we can start some collaboration in the next weeks on the evaluation of this new EGI service. Thank you very much, and have a good rest of the day. Bye bye, everybody.
Bye bye.
Please put the slides not done already.
Yeah, it's already uploaded.
Yeah.
They're already uploaded.
Already
They are there.
yeah,
They are there.
already available.